Good morning everyone. I am Pradeep from BSc Chemistry Honours Final Year. We will discuss about uses of organic and inorganic reagents in inorganic analysis. Reagents are those compounds which are used in inorganic analysis for the detection and determination of ions and molecules. A large number of organic as well as inorganic reagents have been used for this purpose. The inorganic precipitating reagents generally precipitate the inorganic species as sparingly soluble salts or hydrous oxides. The organic precipitating agents from sparingly soluble products either through coordinating linkage or through linkage ionic linkage between the inorganic species and the organic precipitating reagents. Advantages of using organic reagents: they are more specific than conventional reagents under certain conditions. Because of this property, they can be frequently be used to detect a single type of ion in complex mixture. They can be more sensitive. Classical semi micro method of quantitative analysis will usually not detect much less than 100 gammas of a substance under specific test solution. Organic reagents, on the other hand, are capable of detecting below 10 gamma and in certain cases as little as 10 to the power minus 3 gamma. They can be adopted in quantitative analysis. The organic precipitates are generally insoluble in water at a given pH and can be separated, dried, and weighed. Those reactions, giving colored soluble products, frequently show a regular change in color intensity with concentration of the substance under test and so are adaptable to an accurate comparison with colors representing concentration. This is the basic idea in the branch of calorimetry. Common properties of organic reagents. Some of the common properties of organic reagents due to which these are used in inorganic analysis are given below. Formation of colored precipitate. Organic reagents form direct characteristics color with the ions to be detected for locating end points, that is, as detector employed in volumetric titrations. Formation of precipitate due to difference in solubility. This may be made on the basis of gravimetric method. Extraction of organic solvent at controlled pH. Masking reagent. This increase sensitivity of reagents, difference in volatility, oxidation or reduction to other valency states. Wash liquids. The chemical nature of the organic reagent is important in determining the use of above mentioned properties. Advantages of organic reagents over inorganic reagents. It is due to the following properties that they are better precipitating reagent than inorganic reagents. Selectivity. In many cases, organic reagents are somewhat specific. For example, cobalt from nickel using alpha nitroso beta naphthol or dimethyl glyoxime aluminium from iron using copperon, cadmium from copper using quinaldehyde acid. This entire urea can be precipitated. In some cases, adjustment of the pH will often cause precipitation of one constituent alone. By changing pH, the solvent conditions one constituent after another can sometimes be quickly precipitated out. Ease of drying. Organic reagents produce compounds that have little affinity for water and are dried easily at temperature low enough to prevent decomposition. Next is co-precipitation. Lack of ionic character of organic precipitation products greatly reduce co-precipitation in most cases. For example, the co-precipitation of sodium and potassium with magnesium is much less when the latter is precipitated by 8-hydroxyquinoline than when it is precipitated by phosphate or oxalate. Some exceptions in metal do occur. It has been little studied, but in some cases it is as bad as inorganic precipitants. Reagents are usually insoluble in water, therefore it is important not to add an excess of reagent. This is difficult because there is no way to tell when sufficient reagent without excess has been added. Any excess that is insoluble would add to the weight of the precipitate. Disadvantages of organic reagents. Volatility. This is the first practical disadvantage of organic reagents because chelated compounds are non-polar. The forces between individual molecules in the crystal are not very great. The sum of the metallic complexes which are precipitated in analytical chemistry appreciably volatile about 130 to 150 degrees Celsius and most decompose above this temperature. Therefore, the drying of precipitate should be done below 130 degrees Celsius to avoid decomposition. Impurity in reagents. It is very difficult to prepare an organic reagent of the same degree of purity as, say, inorganic compounds. Impurity present in organic reagent may enter into the precipitate during the precipitation and cause desirable reaction. For example, dimethylglyoxime exists in three forms: alpha, beta, and gamma. Of these, only the alpha form is specific for nickel. While preparing dimethylglyoxime, gamma form is also formed along with the alpha form. The precipitation is carried out with this impure dimethylglyoxime, then nickel will be precipitated with some of the metal because alpha form is specific for nickel, whereas gamma can be precipitate other metal also. Keto-enol isomerism is such compounds as dithiazone will cause errors in calorimetric work unless conditions are carefully selected. Low solubility of reagents in water. This is the great disadvantage which organic precipitants have when comparison with inorganic precipitants. High molecular weight. The very high molecular weights of chelate complex formed with metal ions reduce proportionately small errors in precipitation and weighing. Colored compounds. Chelate compounds are often highly colored, and since they are usually suitable in organic solvent, they lend themselves to colorimetric or photometric method of analysis. Solubility in organic solvents. Because of their covalent nature, most of the complexes with organic reagents are soluble in non-polar solvents, chloroform being usually the best. Such solvents are used to extract the complexes for calorimetric determination, or they may be used simply for separating one element from another. Thus, the complex of Kupferan with tri-positive soluble, very soluble in ethane and chloroform, which allow one to remove large amount of iron from the solution containing aluminium. In these extractions, the pH must be carefully adjusted to the given desired separation. Important organic reagents: oxime C9H7ON. Here is the structure of oxime molecule. The structure of this reagent is given here. It is almost a colorless solid soluble in organic solvent and mineral acids. It gives yellow color, which may be due to the formation of quinoid structure. It was introduced by Hallam and Berg. Number of metals give coordination complexes with this reagent. Examples of such metals are magnesium, zinc, copper, cadmium, lead, aluminium, iron, boron, gallium, thorium, zirconium, etc. The formation of the complex compound with a bivalent metal and like Zn2 positive is shown here. The quantitative estimation of the complex is carried out by drying and weighing the hydrated or anhydrous complex or complexes ignited to oxide and weighed. In volumetric method, the precipitation is dissolved in filtering with HCl and then resulting solution is titrated against standard potassium bromide solution. In spectrometric method, the estimation of the metal ion is carried out by measuring the optical density of the complex. The reagent has been found to be suitable for magnesium and aluminium, etc. The reagent is a 2% solution of oxime into an acetic acid. Second is dimethylglyoxime. Here is the structure of dimethylglyoxime. This reagent was discovered by Taschen-Gaff and was applied for determination of nickel in steel. The structure of this reagent is shown. This reagent gives an insoluble red chelate with nickel 2 positive ion in ammoniacal medium. Applications of the formation of chelated complex discussed on basic concept of coordination chemistry. Solution of palladium salts give characteristic yellow precipitate in dilute HCl or H2SO4, but nitrate ion interfere. Solution of bismuth salts also give a yellow precipitate in presence of EDTA at pH 11 to 11.5. For the studies of 1% solution of dimethylglyoxime in alcohol is employed. In spectrometric method, the insoluble precipitate is extracted into chloroform which yield yellow coloration, and then its optical density is measured.